We're now going to consider solutions to non-homogeneous differential equations without a zero on the right. Instead, we're going to have our independent variable here is t. We're going to have a function of t. So we let y1 be a solution to the differential equation with an f1 of t on the right, y2 be a solution to the differential equation with an f2 on the right.
And what we'll see is that if we have a linear combination of inputs, that the response is a linear combination of the output of the responses that we would have had if we had applied F1 and F2 separately. So let's prove that. So y is C1y1 plus C2y2. Y prime is C1y1 prime plus C2y2 prime. Y double prime is C1y1 double prime plus C2y2 double prime. So A y double prime plus by prime plus cy, substituting in for y double prime, y prime, and y, and then factoring C1 and C2, notice that we have C1 F1 plus C2 F2. So the response of the system to a linear combination of F1 and F2 was the linear combination C1y1 plus C2y2.
We're going to demonstrate the method of superposition here with these two solutions. Notice we have the same differential equation on the left, but on the right here we have 3t for the first one and 10e to the 3t for the second one. So here's the solution to this first differential equation and the solution to the second differential equation. Don't worry about where those came from at the moment. We're going to learn how to solve and find these solutions. All we want to do now is show that y equal to the sum of these is a solution to the differential equation with the sum of those two g of t's on the right. So here is our y, which is the sum y1 plus y2. And let's check and see if when we plug that into this differential equation, we end up with 3t plus 10e to the 3t on the right. So as our check, we get y prime is equal to 3 halves minus 0 plus 3 halves e to the 3t. And here's y double prime, of course, 0 plus 9 halves e to the 3t. We plug into our differential equation here and get what you see right here. Y double prime plus 3y prime plus 2y, and the 9 halves go out here. We have a 3t here. We have a 9 plus 1 right there, e to the 3t. So indeed that does check and gives us 3t plus 10 e to the 3t.
The superposition principle is what we will use to create a general solution to a non-homogeneous DE. So let's let y sub p be a solution, called the particular solution, to this non-homogeneous second-order DE. Then y sub h is the general solution to the corresponding homogeneous DE, this same DE with g of t 0. Now, some textbooks or other materials you may see the homogeneous solution designated as y sub c because sometimes it's referred to as a complementary solution. So we have these two equations. If we add them, notice what happens. I have y sub p double prime plus y sub h double prime plus p times y sub p prime plus y sub h prime plus q times y sub p plus y sub h is equal to 0 plus g, or g. So that means if I look at the sum of y sub p plus y sub h and just call that y, it's actually a solution to the non-homogeneous DE. So let's state that result formally as a theorem. Every solution to this second-order non-homogeneous DE on the interval from A to B can be expressed as the sum of a particular solution and the homogeneous solution. So the procedure for solving non-homogeneous DEs of this sort determine a general solution to the corresponding homogeneous equation. Notice we have the two arbitrary constants here in y sub h. Find a particular solution, y sub p, to the non-homogeneous equation, and then form the sum to obtain a general solution. Our objective asks us, if we are given a particular solution to a non-homogeneous DE, to find the general solution.
Here we're given a particular solution of y sub p is equal to t minus 1. Again, don't worry about where that came from. We're going to learn how to find particular solutions in the next objective. So what we want to do is find the solution to the corresponding homogeneous equation. And we get this in operator form, d squared minus d minus 2 operating on y is 0. That gives us this auxiliary equation, which factors. We get r1 is equal to minus 1, r2 is equal to 2. So we get the homogeneous solution, c1 e to the minus t plus c2 e to the 2t. And all we have to do for our general solution is to add y sub p and y sub h. And that's what you see right here. Based on the superposition principle, that is a solution to that given non-homogeneous differential equation.